Let us continue our discussion on PDA to CFG conversion. Let's look at this language a power n b power n, where n is at least 1. So PDA with acceptance by empty store is like this: delta of q naught comma a comma z naught is q naught comma a z naught, and delta of q naught comma a comma capital A is q naught comma a. So using q naught, we push a's, then delta of q naught comma b comma capital A is q1 comma epsilon. So delta of q1 comma b comma a is q1 comma epsilon. So using q1, when at q0, when we read the first a and the top symbol is capital A, we pop, and with the help of q1 we pop the remaining b's. Now delta of q1 comma epsilon is at naught, we say we reach some final state, we say qf comma epsilon. Okay. Or we can stay at q1 and say q1 comma epsilon. So what we will do, we will stay at q1 and we say q1 comma epsilon. And there are other transitions. For example, q0 comma b comma z naught, we say reject. So what we have written is only the valid part. Using this you can read a. Using this you can read B, pop a, and with this you conclude it's a valid string and stop your procedure. Supposing we are going to employ our conversion procedure for this PDA, so what would be the start symbol? Start symbols will be q0, because q0 is our start state. Start symbol of the stack is z0, then this could be q0 or q0 z0 q1. Then we will write for this we will write it as q0 comma z0 implies a, output state is q0, and in this case this is b1, this is b2. So a comma say q0 and q0 comma z0 comma q0. This one is, it could be any qi from q, so we look at possible values. Since this is ending in q0, so this is q0. Or q0 z0 implies a, output state is q0, a, q0, q1, q0, q0, z0 followed by q1. Since this is q1, this is q1. Or q0, z0 implies a, q0 comma a comma q1 comma q1 comma z0 comma q0, because this one is q0. Or q0 z0 implies q0 a, q1, q1 z0 q1. So therefore this one is q1. So now you see that it is q0 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 but ending in q1, or q1 q1 ending in q0, q1 q1 ending in q1. So it's like this. Starting from this non-terminal or this non-terminal, subsequently we choose one of these productions to read the subsequent A's. Then after reading one A, You may choose this or this to expand further, and you keep doing this to read subsequent A's. Now, what about this? This says Q naught A implies small a, output state is Q naught, it is A. So it is A followed by Q naught capital A followed by Q naught. Therefore, this one is Q naught. Or it is Q naught A implies this Q naught A, Q naught A, Q1. This one is Q1. Or Q naught A implies this Q naught A, Q1 A, Q naught. Therefore, this one is Q naught. Or Q naught A, Q1 implies A, Q naught A, Q1 A followed by Q1. So starting from this, we may take Q naught Z naught Q naught implies this. Then how do you expand this or this? Here is a rule that says Q naught A, Q naught, if you take, you can read one more A and have these two non-terminals. So which means with this, you can read so many A's. Now we should take care of the pop operation. Let's get into that part. So look at this rule. This rule says Q naught capital A Q1 implies this. This rule says Q1 capital A Q1 implies this. And this rule says Q1 Z naught Q1 this. So in fact, we may not use all of this. Some of these productions we realize that it may not be useful as part of our derivation, because somewhere down the line we will have to terminate, which means we will have to generate a string involving A's and B's, A square, B square, A power 4, B power 4 and so on, for which this will eventually help us. Fine. So let's look at one trace so that you can appreciate how things work. So let's look at AABB. So we will have to start from this or this and proceed. So let's look at this and one can decide based on that. Supposing you start from this, say Q naught Z naught Q naught, then you take this or you take this. There are two possibilities for Q naught Z naught Q naught, right? So you either take this or this. Supposing you take this Q naught A Q naught, this part. Now for this Q naught A Q naught, you can take this or this. And what about this Q naught Z naught Q naught? So for this we need a terminal. But is it defined here? No. So instead of this, supposing I take this. Now for this, is it defined? It says Q1 Z naught Q1. So you realize that for this it is not defined, for this also it is not defined. Okay. So if I start from here, I will have to choose this or this, and using this or this, you will subsequently derive. What about this or this? But for this, there is no rule that says it leads to a terminal. Similarly, there is no rule that says this leads to a terminal. Which means, starting from this, if you take this or this, we will not be able to perform derivation of a string like this. Okay, let's start from here. Suppose I take Q0, Z0, Q1. Then I can take this or I can take this. But this one is defined. Q1, Z0, Q1 is defined. So I'll start from here. Then I'll take this. Then this one is defined. Then what about this? Now Q0, A, Q1, you can either take this or you can take this. Let's verify. So suppose I take this. Then what happens? Q0, A, Q1. It says Q0, A, Q0 followed by Q0, A, Q1. And Q0, A, Q1, you can still apply this. What about Q0, A, Q0? You can take this, apply, or you can take this and apply. Okay. If you don't take this, supposing I take this, then this will give you Q0, A, Q1, and for this Q1, A, Q1, it is defined. Okay. So between these two, which one we should go for? Let's try this. So let me start from Q0, Z0, Q1 implies A followed by Q0, A, Q1, Q1, Z0, Q1. Now you have Q0, A, Q1. Let's assume I take this. Then Q0, A, Q1 is you have one more A followed by Q0, A, Q0 followed by Q0, A, Q1 followed by Q1, Z0, Q1. Fine. Now you have Q0, A, Q0. So you will have to take this. But if you take this, there is no termination for Q0, A, Q0. Supposing I take this, then you get Q0, A, Q1 followed by Q1, A, Q0. But Q1, A, Q0, there is no rule. So which means if you proceed with this expansion, we will not be successful. So this is what we have taken. So we should not take this. Instead, we should take this. So if we take that and derive, we will get Q0, Z0, Q1 implies A followed by Q0, A, Q1, Q1, Z0, Q1. Then for Q0, A, Q1, we employ this rule Q0, A, Q1, Q1, A, Q1 followed by Q1, Z0, Q1. Now Q0, A, Q1 is B. So we get B for this. Q1, A, Q1 is B. Q1 Z naught Q1 is epsilon. So therefore we get AABB. So this clearly tells you between these two we should start here, and starting from here we will not be able to derive a meaningful string. So which means starting from this, whatever productions you see, they are all useless. They contain symbols that one cannot reach. Or with that, if you expand, you will not be able to generate a string of terminals. But from this, you go over here, and subsequently when you see Q0 A Q1, you will have to decide whether to take this or this. We see that if we take this, we are not deriving anything, whereas if we take this, we are deriving. Which means you can simplify this further and go for change of variable. So if you call this one as S, so you get S, and then you look at this one as S implies A followed by Q0 A Q1, then Q1 0 Q1. Q1 0 Q1 implies epsilon, and there are no recursive rules on that. Fine, so we will leave this part. For this part, it is capital A implies, you get to see that it is A, capital A followed by B. B is this non-terminal, Q1A Q1. Fine. Now for this A, again you get capital A, small a, capital A, B. Fine. Now we want to terminate. What is A? It is Q0 A Q1, and Q0 A Q1 says it is B. What about capital B? Capital B says Q1 A Q1, that also says B. So this is precisely our CFG. Now this is different from our usual one, which is A is B and S implies AB. This we come up with just by looking at the underlying set, but this one we derive from the given PDA. Just like the way PDA derives, this grammar simply simulates how exactly PDA recognizes A square B square. So first PDA reads one A, and then it looks for subsequent A's. So that's precisely is what this says. But this is so careful that for every A, one B is also there, so that you can match later. And if you want to terminate, you take this and terminate, or you take this, substitute and terminate. Supposing you have derived say 7 capital A's, and you would have derived so many corresponding capital B's as well. Okay, so that shows that at any point in time you have equal number of A power n followed by B power n. The simplest one is substitute B here, you get AB. Otherwise you go for this and you substitute here, you get A, capital AB, and you can terminate using these two or go for further recursion. So which means this one is useless non-terminal. This one, this one, this one, these productions are also useless. Similarly, these three productions are also useless. And if you employ our classical simplification of CFG algorithm, we will realize that we will be left with this, this and this. All other productions or removed. So you practice with couple of more examples, so you can see that PDA simulation and CFG derivation, they are consistent. They are one-to-one mapping. Fine. So quite interesting stuff. Given a PDA, how to come up with an equivalent, the corresponding CFG. So far, what we have seen as part of typical examples like a power n, b power n, or a power n, b power m, where some condition on n and m, we were just looking at the underlying set, and then based on couple of strings, we derived the recursive formula. But this says one can just focus on how exactly a string is accepted. That simulation, you can model it as a grammar. Fine. So a couple of questions like this, let's experiment more as part of tutorial session.